Hello and welcome to this Apache Spark tutorial. In this video, we would have a look at how to convert an RDD of strings or a dataset of strings into a structured data frame. I encountered this problem while designing a streaming solution for a client where the data would be coming in JSON format, but the format was not predetermined. I could not hard code it into the code because I did not know the format prior to writing the code. The format had to be end user configurable. It was to be given in a config file by the user, not by the programmer. So for that reason, you can obviously see why I could not hard code it. In this video, we would take a look at two approaches. In the first of which, we would use the Scala case class to convert an RDD of strings to a structured data frame, and that would be hard coded. Yeah, like the schema would be hard coded in that approach. In the second approach, we would take a look at how to use RowEncoders to convert strings, simple plain strings, into a structured data frame, which is the approach I used in that solution as well. So let's jump right into the video. In the description, you can find the link to a blog post where I have described both the methods. I myself would be referring to it to copy commands from it. And you would also find a link to the data that we'd be using in today's video. So the data is just a simple set of JSON strings. I have already downloaded it, so I am not going to do it again, but you should. And let's just go ahead and launch our Spark shell. And while launching the Spark shell, we would also give Maven coordinates of a JSON library. I tend to use org.json. If you're using something else, it's fine. It's up to you, whatever your preferences are. All these commands you would find in the blog post as well. So for the first method that I told you, we'd be using a case class. In that method, we would need an RDD of strings instead of a data set of strings. So if you have a data set, it's not a big deal. Just suppose if your data set is called ds, just write ds.rdd and you would have an RDD instead of a data set. All right. So it's because the Spark API only allows RDDs of case classes to be converted into structured data frames. All right. So let's just go ahead, read our data as an RDD and then convert it into a data frame using a case class. So step one would be reading our data, of course. So in here, just write the path of wherever your file is of the data that you've just downloaded. I'm sorry, it needs to have a name as well. So now we have read data into this RDD variable. Let's just confirm this is the data that we want. So as you can see, it's a set of strings, JSON strings with certain fields, user ID, date, time, OS, etc. So the next step, in the next step, what we're going to do is we're going to create a case class. And in that case class, we would have all these fields, user ID, date, time, OS, with all the data types that we want. You can parse it however you want, but since I'm going to parse date time as a timestamp, I'm not going to parse it as a string. If you want, you can, nothing's stopping you. But for the purposes of this video, I'm going to parse it as a timestamp. I would need to import the timestamp class first. So let's just go ahead. After that, we would need to create our case class. You can name it, of course, whatever you want. I already have it written over here, so I'm not going to write it again and again. Remember, you can find all the commands on that blog post if you would like. So now we have just created a case class for this data. Now every row we would need to parse it and pass it into this case class. Then we would get an RDD of clickstream class, right? We would get an RDD that holds objects of clickstream class. After that, we just need to call 2df on that RDD and it would be converted into a structured data frame. So let's just go ahead with that as well. We are going to map all the rows of this RDD and convert them into an RDD containing clickstream objects. So before we can map it, we would need, of course, I forgot, we would need to import the JSON object class, and we would also need to import the date format class so we can specify the format in which we want our dates to be. Let's just let it go to waste. All right. Now we have specified our format. We have imported the JSON object class, and we have also imported the simple date format class. After that, as you can see here, we'd be parsing every row. X would be one row of the RDD into a JSON object, and then from that object we would get user ID, which is a long. We would get date time, which we would parse into, we would get date time as a string, and then we would parse it into a timestamp. And then we would get OS as a string, browser as a string, and response time as a long, and URL as a string, right? Just throwing some error, just give me 1 second. Oh, stupid me. I would fix the blog post as well. So now we have parsed the JSON strings as an RDD of of clickstream objects. Let's just go ahead and take a look at this RDD as well to make sure the data is what we want it to be. Right. So here you can see we have various objects of the clickstream class, and now the next step is the simplest step of all. Once you have an RDD of some case class, you can just go ahead and call the toDef function on it, and it would be converted into a data frame. Voila. So that was the end of the first step. We started with an RDD of strings, and now we have a data frame containing all the columns and all the data. And let's head right over into the next method, in which we'd be using encoders to convert a data set of strings into a data frame with structured columns. Let's move on ahead to the second approach that we talked about, in which we would be using RowEncoders. For the purposes of this example, we would be taking a look at a very specific case. Let's say we had the data coming in as JSON strings, and we had to do a group by on it on a list of columns, and then we had to do an average on a column which would be specified as a string. So to accomplish this use case, the data might be coming in very varied formats. The JSON strings might be of 1,000 different kinds of formats, but they would only need to have the columns which are stated in the group by list, or the column that is stated as a string on which we have to do an average, right? So we would not need to extract all the columns or parse all the columns of the string. We would only need to extract a subset of those columns. As with the previous method, feel free to open the blog post and follow along. I would be referring to that as well. So the same problem has been given in the blog post as well. So in this, the first step would be the input that we should be taking from the user. So I told you we'd be having a list of columns on which there has to be a group by operation, and then there would be a column specified as a string. In this list, I'm also specifying the data type of that column. In our case, it's string for both the cases. List, the OS is string and the browser is string as well, and the response time is given in integers, right? So I'm just going to copy this into my shell. As said before, the group by columns list is the input given by the user. All right, this is just to simulate some input that the user can give us. After this, we would go on ahead with our code. Step 1 would be to read the data as a data frame of a string or a data set of a string from from our folder. So once again, go to your folder, copy the path, and then just parse it into a data frame. Let's make sure the data has been read. So this is what the data looks like right now. We have read it into a data frame of string, as you can see here. Data frame with the format string. There's only one column, value, which is a string. Our objective is to extract 3 columns from it: OS, browser, and response time. Then do a group by on OS and browser and do an average on the response time. Alright. So to accomplish that, first of all, we would have to give a schema for the final data frame, the one we would parse it into. In the final data frame, we would have only 3 columns, right? OS, browser, and response time. So the schema should be OS, which would be string, browser, which would be string again, and response time, which would be an integer. So we would have to write a schema for in Spark format, which is a struct type. Then we would run the encoder method. Then we would convert it into a row encoder. So first of all, to define the schema, we would need to import the struct type, which is under SQL.types. All right. So I'm importing all the types, which includes struct type as well. And when we would convert it into a row encoder, we would also need to import the row encoder. All right. And now let's go on ahead and specify our schema. I declared a new variable schema with struct type. Now, since we are simulating user input, we are taking this the string and the list of the string name as a column and the list of columns defined before as the user input. We we are going to go on ahead, create a for loop, and create a final schema and row encoder. So as you can see here, I'm reading from the from the list of columns, which are in group by columns, and the one column on which we have to do the average, and then I'm adding the name of the column and the schema of the column to my schema. All right. Once I'm done with that, I can get a row encoder directly from it. And now we have an encoder for the types given by the user. So after this, when we parse the data frame into a structured data frame, we would need to pass this encoder as an argument to a curried function, right? We use curried functions in Scala. Before I can parse, of course, I would need to import the JSON object class as well, because I would be using it to read JSON objects from the string. And I need to import list buffer because I would be creating a list out of it. So I would like to explain one thing here. The reason I had to go with a data frame and I could not use a dataset was because dataset in the end would require me to give a tuple, and I cannot have a tuple of variable length. I would have to hard code a tuple. I couldn't. There is no way in Scala to have a tuple which can have 2, 3, or 4 4 number of elements. You would have to hard code it into the code the number of elements it would have. So since data frame uses row, which can have a variable number of arguments, I had to go with the data frame, and the encoder is passed as an argument to a curried function after you're done with the map function, right? So here I'm doing a similar thing as last time. I'm creating a new JSON object from the row that I'm reading from the data frame. Then I'm creating a list buffer in which I would add the particular columns that I would read. Again, my group by columns and the column on which I have to do the average. I would read them from this object, I would add them to the buffer, and finally I would convert them into a list and pass that list as arguments to to the row object. For this data frame, I would get a row of 3 objects, which would be my OS column, like the data from my OS column, the data from my browser column, and the data from my response time column. And I would pass the encoder and this would give me a data frame which would look something like this. Alright, so let's just go ahead. Let's take a look at the data. As you can see, now we have got only 3 columns, the 3 columns that we need, and everything else has been discarded. We can you can say the work has been done at this point, but we would just go on ahead, do the group by and the average. So since we are simulating user input, the the group by cannot be hard coded as well. It has to be read from the list that we have been given, a list of tuple which contains the name of the column and the type of the column, right? So I'm sorry, just give me a second. Alright, I accidentally copied 2 rows instead of 1. So what I'm doing here is, on my past data frame, I take the group by columns, I map the first element of the tuple, then I take its head means the first element, and tail would be the rest of the elements, because the group by method requires me to give at least 1 argument. So that's why I had to do a head and then all the other columns as tail. And then I would do an average on the column that has been given to us, the response time, right? Response times first element. And now we have the output res4, and if we do show on it, you should have your results. So that's all for this video. I hope I helped. I hope you learned something new. And if you have any other questions regarding Apache Spark, feel free to contact me. If you have any other questions regarding Scala, feel free to contact me. If you have a difficult problem that you're stuck with on Spark, feel free to contact me. You can leave your queries down in the comments. And thank you very much.